Hello, grade 9s. We've looked yesterday or the day before, we've looked at similarity, and that is when two shapes are the same shape but not the same size. Okay, and today we're going to look at congruency, and congruency means that the shape is exactly the same size as well as the same shape. Okay, so congruency just means that it's exactly the same size and same shape. And we indicate congruency with three horizontal stripes like indicated. Okay, there are 4 conditions for congruency in triangles, and we might have looked at this last year already, where you can prove that two triangles are congruent to each other by side, side, side. It means that all 3 sides are the same size or the same length. Then you can also get side, angle, side. That you must have the angle must be included or in the middle of the 2 sides. So it's a side, and then in between the 2 sides are an angle that are also equal to the other triangle's angle. Then you also get angle, side, angle, as indicated there, an angle with a side and also another angle. And then the last one must be a right-hand hypotenuse side. Okay, a right hand and a hypotenuse at the same, and then any side. Okay, and that is the terms for congruency, or the rules or the properties to prove congruency. Okay, let's explore each property quickly separately. Okay, 3 sides that are equal in length. Okay, I think that is quite easy. You have a side, and a side. Okay, one side and 2 angles are equal, so it can be from any side depending on where you take it from. I'm going to quickly put on my pointer. Okay, so if you've got a side, and then an angle, or if you took it from this side, angle, angle, side. Sorry, I think I said. Okay, 2 sides and one angle are equal. Okay, but the angle should be in between the 2 sides that are equal. So it doesn't matter from which side you take, it's going to be exactly the same. So side, angle, side, or if you took it from this side, side, angle, side. Okay, and the last one, right angle, hypotenuse. So across from the right angle is always the hypotenuse. So that would be 5, and there's that one, 5 as well. And then any other side could have also been given as the same. So either this one or that one. Okay, we always work with the following format. The same with the similarity. The order of the write-up is very, very important. So they say to you, prove that triangle ABC is congruent to triangle ADC. So note that it is proof that they are. So it means that they are actually already. You just need to prove it. Okay, like I said, the order that they do the write-up is very, very important. So let's just have a look at that again. So if they say to you that triangle ABC, you need to prove that triangle ABC is congruent to triangle ADC. What does that mean? The write-up, remember, A is equal to angle A is equal to angle A, angle B is equal to angle D, and angle C is equal to angle C. Okay, I've written it there, but it also means that AB is going to be equal to AD, and BC is equal to DC, and the first and the last, AC, is going to be equal to AC. Okay, so that should give you a good indication as to what is equal to what, and you just need to get the right reason for why they are equal to each other. Okay, so let's quickly have a look how we would write this up. So you're going to say angle B is equal to angle D. All right, so we've got an angle there, and that's 90 degrees. That's been given. Okay, and then also AB is equal to AD. That's also been given. It's on the sketch, written there. The only thing that you now have to see is, there's another side that's equal. AC is equal to AC. Why? Because that is a common side. Okay, so we've got an angle, side, side. Let me just quickly get my cursor out. Okay, sorry. So we've got an angle, side, side. Okay, but now, very important, you cannot have ASS. Okay, that spells a donkey. You cannot have that. So the only reason that, or where you can have an angle side, side is if it forms a 90-degree hypotenuse and a side. Okay, so very important. We cannot, if this wasn't 90 degrees given, then you couldn't have written it up as congruent. Only if it's an angle and a side, that spells ASS. And I think your teachers taught you last year, we don't have a donkey. We can't have a donkey. That's the only one that doesn't prove congruency unless it is a right angle hypotenuse. All right, let's quickly have a look at example 1. So they've given you JN and KM are straight lines. Prove that triangle JLK is congruent to triangle NLM, given that JK is equal to MN and J is equal to N. Okay, I'm going to quickly get my pointer here. Okay, so they say to you, okay, so if you look at this picture, what has been given? JK is equal to MN. All right, that has been given. And so your write-up is going to look like this. In triangle JLK and triangle LNM, and NLM, sorry, the following I can see. Okay, so JK is equal to MN, that has been given. And then you don't have to do this, but I just always note on the side here, I just call it side. It's a side that I've proven is now the same. Then also J is equal to N because it's been given again. That is an angle. And L1 is equal to L2. That angle over there is equal to that angle over there. And we know this through vertically opposite angles. And that is an angle. So you can see the reason here is side, angle, angle. So you can say the triangle JLK is congruent to triangle NLM. Okay, example 2. They say to you in triangle PQM and triangle PRM, it is given that M1 is equal to M2 and PQ is equal to PR. Okay, so first of all, they ask you to prove that triangle PQM is congruent to triangle PRM. Okay, so you're going to always start with in triangle PQM and triangle PRM, the following I see. Okay, M1, all right, so you can't just say M1 is equal to M2 because this is a very good example of that hypotenuse, right angle hypotenuse side. If I just proven that that angle is equal to that angle, then I would have had an angle, a side, which I'll show you now why that one is a side, and a side. Okay, and that spelled backwards is ASS or SSA, which spells a donkey. Okay, and we cannot have that. Okay, so the way to go ahead to prove that they're congruent is to prove that actually M1 and M2 is both 90 degrees, because then you'll have 90-degree hypotenuse and any other side. Okay, so we're going to start with that. M1 and M2 is equal to 180. Why? Because it's angles on a straight line. Okay, but M1 is M2 because it's given. They told us, but M1 is equal to M2. Aha, thus M1 and M2 must both be equal to 90 degrees. Okay, so now we've got 90 degrees, and then PQ is equal to PR. Okay, those two sides have been given as equal in length. So that has been given. Okay, and that is the hypotenuse. And then PM is equal to PM. Why? Because it is a common side. They share that length, that side. So the length must be the same. Okay, common side. So I've got a side. So I've got my 90-degree hypotenuse side. So they are congruent. And what is your reason? 90-degree hypotenuse side. Then they say to you, prove that QM over there is equal to MR. Okay, but now remember, we've already proven that that shape is exactly the same. The one triangle on the left is exactly the same as the other triangle on the right. So through actually showing that they are congruent, it means that those two lines are automatically the same length. Okay, so all you need to write down, and lots of people get scared with these questions because they don't know how to interpret them or how to write it out. You're just going to say, yes, they are equal. Why? Because I've proven that those two triangles are congruent. I know that this is exactly the same as that. I know that this is exactly the same as that. I know that this is exactly the same as that. I know that that angle is equal to that angle. I know that that angle is equal to that angle. I know that that angle is equal to that angle. So actually these two are exactly symmetrical as well, because if you had to fold it, they will fold exactly onto each other. Okay, so all you need to do there, and it's normally for 2 marks at the end of the question, you just say, well, they are equal. Why? Because I've proven that they are congruent. Okay. And I think that is it. Thank you, grade 9s, for watching, and please go and try these on your own now. You always do get a question like this in the exam, so please, it's very important that you understand this. And please reach out to your teacher if you've got any further queries. Thanks, and have a wonderful day. It wasn't the last slide. Here's the last slide. Just quick example 3. Okay, so they say to you, please prove that these two triangles are congruent. Quickly, you can see that AC is going to be equal to CE, and BC is going to equal to CD, and C1 is equal to C2 because they're vertically opposite angles. Okay, and then you can prove it with side angle side, and then they ask you, prove that AB is parallel to DE. Okay, AB is parallel to DE. Okay, but now you've already proven that A is equal to E, or the other way around, B is equal to D, because they are congruent. So it means that if you look at your write-up, let me just add my cursor here. Okay, so if you see your write-up, you can see that A is equal to E. So A is equal to E, and B, middle one, is equal to D, middle one, middle one. So aren't they then, what is that? Z that forms like that? It's alternate angles. Okay, and if alternate angles also the other way around, if they are, if those two angles are the same, it means that those two lines that they fall in between are parallel. Okay, so let's have a look how we would write that. So A is equal to E. I've proven that they are congruent. So AB is parallel to DE because of alternate angles that are equal. Okay, I hope that